This is a recap for Tuesday, April 6th. So we took a quiz at the beginning of class today. And here are the questions. Is this direct variation y equals 2x? The answer is yes. And this is just one of my classes, or 75% of the people recognize that. Number 2, does the table represent direct variation? And there's no picture of this table here, so we can't really, oh, there's the table. So it has 1, 6, 2 and 12, 3 and 18. So the multiplier is 6, and I'm going to make a guess as to why 5 people said no, and maybe because they didn't see the 0, 0. So 0, 0 could have been on this, because 6 times 0 is equal to 0. So the answer on this was yes, it shows direct variation, even though 0, 0 was not on that particular table. Then let's click on this one, write the equation for the table. So 3 times x is equal to 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4. So this is 3 times x is equal to y. So y equals 3x. Which of the given graphs is direct variation? So the only one that goes through 0, 0 is C. And I'm a little surprised that we didn't get a higher percentage correct on that. And so we'll have to keep working on that. What ordered pair does the direct variation always go through the origin when graphed? What ordered pair does the direct variation always go through the origin when graphed? And that is 0, 0. Again, a little surprised on that one. Write an equation for this relationship. And so the picture is that we multiply 8 times 1/4, or divided by 4. 8 divided by 4 is 2, 16 divided by 4 is 4, 24 divided by 4 is 6, 32 divided by 4. So multiplying by 1/4 and dividing by 4, that's C. And so that's definitely something that we're going to need to work on. What is the name for K? And that is the slope. About half of us got that. Which graph shows direct variation between x and y? And again, the lower half saw that it was A. It has to go through 0, 0 to show direct variation. And is this direct variation? And the reason it's no is because it has a plus 4. If it was y equals 12x, then it would be direct variation. And number 10, y varies directly with x, and y is 16 and x is 32. Which equation? So that would be 32 divided by 16 is 2, so we need y equals 2x. Whoops, I said that incorrectly. And that's how 4 people did what I just did, and that is y equals 2x. But x is twice as big as y, so we have to cut it in half. So it's y equals 1/2 x. Which variation is represented in the graph? And I meant to actually have this one be edited out, so I'm not even going to look at that one. We're going to just throw that one away. Is the given table direct variation? And again, we can see the multiplier times 3. 5 times 3 is 15. 6 times 3 is 18. 7 times 3 is 21. 8 times 3 is 24. So we say yes. And the multiplier is 3. And which of the following represents direct variation? Y equals kx. About half of us got that. And true or false? The length of time you charge your cell phone and the battery power is direct variation. And that is true, because if you have 0 minutes charging your battery, then it will have zero charge. Now, I'm not sure if there is a constant of variation, so that may actually be false. And so that was the quiz that we took today. And then we did this. We worked on Jamboard, and I'll just show you real quick on a whiteboard what we did. We thought about direct variation in 4 different ways. So first of all, we just wrote a sentence. For example, y is twice as big as x. So just a sentence. Whoops, let's just put that sentence right there and we're all done. And then we wrote an equation. Y equals 2 times x. And that really says the same thing. See if I can still move. I don't think I can move that. Okay, and then we made a table. The table looked like this. It's an XY table. And we just chose 3 values of x, like 0, 2, and 4. And then we did this. Y equals 2 times 0. What's doubling 0? Doubling 0 is 0, so that's that value. And then y equals 2 times 2. We double 2 to get 4, so that's right there. And then we did y equals 2 times 4, and we get y equals 8. So when x is 4, y is 8. When x is 2, y is 4. When x is 0, y is 0. And then the last thing we did was we just sketched out a graph. This is the x-axis, the y-axis, 1, 2, 3, 4. We can count to 5. 1, 2, 3, 4, 5. And then I'm counting by 2s here, just so that I can get up to where I need to get to on the scale. 2, 4, 6, 8, 10. And then this, remember, is the point 0, 0. So we put that right there. This is the point over 2 up 4. So over 2 up 4. And this is the point 4, 8, which means we go over to 4 and up to 8. So I'll kind of do this so we can really see where that point is coming from. And then we could just draw a straight line. Undo that a little bit. Just got a little stuck. And let's just redraw that straight line through those points like that. And that should be straight. In fact, I could just go like this. And we don't want it white because it wouldn't show up. Let's make it green and go like this. And it really would be a straight line through those points like that. We'll just kind of clean this up a little bit. Okay, so that is a recap of direct variation that we talked about and the activities that we did on Tuesday, April 6th.